Hello and welcome back. My name is Corey and you're my rubber ducks for the evening, and this is the series of episodes where we are creating a programming language from scratch using C++, basic tools like Flex, Bison, Google Test, ICU. You'd think I'd have this memorized by now, but I don't. I had to think about it every time. And Vim is our text editor. We are working out of a console window, out of a terminal window, and you've been able to access the entire history of this project. I've been 100% live coding, nothing up my sleeves, nothing pre-prepared. And today we are going to do what I have been putting off for so long, and that is we are overhauling the Makefile. What's the problem with the Makefile? It's ugly. It's bad. And it's incomplete. And so, you know what? If I do WSL view docs HTML index just to open up our documentation, the problem is that if we go into stuff like, well, let's look at the classes. And in the file list, sure, source, AST node. This is what its inclusion looks like. So it should include opcode. So if opcode changes, the AST node.o needs to be recompiled. The problem is we have to maintain that list of things that needs to be updated separately. Specifically, I just got to get there. No, that is the wrong thing there. Oh, wait. Well, I'll do that in a moment. Specifically, if I go to our Makefile and just look up AST node, not that one, not that, oh my. Once we get past these, we'll be okay. Yes, this one right here. We have to keep this list updated, but it also needs to it needs to be updated with what is included in the .hpp file, in the header file, as well as in the .cpp file. So we had to keep track of both of those. And in an earlier episode, I did at least get rid of the cycles in the HPP files. But yeah, it's just, this needs to include program, which needs to include error. So if error changes, ultimately, AST node should be recompiled. Yeah. Why? Because error may change something in program, which then that would need to change something in AST node. In other words, it's something big and complex and ugly, and I have shied away from it because I knew how big and ugly and complex. And quite frankly, I didn't quite know how I wanted to solve it. The problem with recording videos is that you almost have to be an expert on something, and I am not an expert on any of this. I'm learning along the way, and I'm learning new things, and it's hard to put yourself. I have a PhD in computer science. You'd think that I'd know everything. Nope. Most professors don't. We just keep right ahead. We tried to keep right ahead of the students, because technology is always changing. I'm not saying there's stuff we don't know, but and there's so much to know in computer science. And anyway, yeah, all that to say is, so where are we now? Where does this put us? Well, first of all, on the right-hand side, we're going to do our make clean and remove everything and make test watch and just get that going. So we can make sure we've got a fresh compile and everything. On the left-hand side, what are we going to do? We're going to say get status. Nothing has changed. I've always said nothing up my sleeves. I haven't pre-prepared anything. And then if we say get log, the last commit was episode 80, the previous one. We are on episode 81, and it is New Year's Eve for me. So don't I know how to party, It's early in the afternoon. Who am I fooling? I don't do anything. Anyway, all right. I'm a boring person. we're going to look at the Makefile and just see. I did do the one change where I pulled all of these out, put them on their own line, put them in alphabetical order. And now we're going to see if we can simplify a lot of this. One of the things that I'll point out is that we've got the exact same thing, almost. Exact same thing each time. And that should go away. We've got a separate role for each one. And okay, all of our tests are passing. I was looking up, do I have this open? Not that one. Here we go. I was, horror of all horrors. I went to the documentation and started reading up on Makefiles because, quite frankly, Makefiles are something that I was never taught. I've only used them as I've needed to use them, off and on, infrequently, and probably pretty poorly. And so, just reading through, this is how variables work, or how it's how everything is determined. I didn't know until I was, kind of getting ready for this, that I could do, make-p, and well, let me pipe that into less. That way we see everything, and it will tell me all of the variables that it's using and kind of where it's found them. So if we look, you'll see, okay, yeah, there's there's the path variable, or look, here's all of the lib objects, and I didn't know it. It had a CPP already defined, and that is of course C preprocessor, not C++, C preprocessor, and that's where it calls CC with the -e thing. So anyway, all right. Just looking at the color stuff. Sorry. Okay, that's it. I'm going to get out of this. Let's go back to the make test watch. Okay. Now, how do we simplify this? Let's start off. I'm going to make a copy of this first rule. And let's see what we can abstract out. I know that if I put a %O and I can say that that is based on the %CPP. Can I now say compiling $@ that's the target, everything else should be the same. Okay, so here's the what I'm looking at, or what I'm thinking. I know that in not this picture, but in this one, for overriding, not that. Let's look overriding variables. Yeah, I know I can do it with an equal sign, but I don't think that's not the one I was looking for. Let's go back to overriding variables. Really, it's the overriding recipes that I want. Okay, it's just, I'm halfway through the file now, so go back up to the top. Writing recipes. Oh, jump down to there. And using variables in recipes. And recipe echoing, execution. Okay, I know that you're in here. One moment. This is worth showing you if you don't know about this. Maybe it's the rules. Searching directories. Huh. Or is it under variables? Oh, okay. Setting variables, blah, blah, override, defining multi-line, variables from the environment, target specific. There we go. Okay, so what we can do is something like this. If you have the target and the colon, and then you set C flags, and then now I've got the target and the dependencies, it will apply this variable to all of these dependencies. So I start thinking about that. It's like, well, that's kind of interesting. Oh, and it's got some stuff about pattern specific, but I don't think I need that here. Well, let's just look and see what I was looking at. So my thought was, first of all, right here, this is the object directory, source percent, compiling, all that. Okay. Now, the problem is, first of all, I'm assuming that everything in the object directory that gets compiled with the %o needs the source and source.percent.cpp. And that is not quite correct, because we have some that it's past all the AST nodes, past the computer. Yeah, like this one right here. Tang parser.o, its Tang parser.cpp is in the generated directories. And there's a couple of these. So, what do we do now? Well, getting back down to it, we want to kind of limit these to specific things. So what I know that didn't make any sense to you, but it made perfect sense in my head. What I'm going to do is I'm going to create a gen lib objects, and it's going to have a few things in it. Let's pull out HTML escape. So this one, escape ASCII %encode. So if I remove those, paste them, that's not the only ones though. I think my parser and scanner and my unescape, I think that's the only ones. And of course, there, now they're back in the right order. So now they're, all right. If I do this, it's not, the first change I've got to make is now these are not included in lib objects. And so when we compile our target, our big target of lib objects, we now need to specifically include gen lib objects as well. And as of this time, if I say make clean, what? That doesn't make sense. I've already broken it. It's not because I did that, is it? Oh, well, let's undo that and let's fix that. Recipe commences before the first target. Oh. Okay. Now it's working. If I just try to run make test, okay, I'm stopping it at this point. Why? Just so we can look and see what it's doing. HTML escape. I mean, so all of this, it's still doing everything. So then the question is these right here. What I think I can do now is I think I can say delete this, delete that. There's going to be a lot of deleting. So there's how many are there? Maybe 60 some odd? Nope. Basically, I'm hitting D to enter, to enter. And we're just now to the, we got past the AST nodes. Nope, see? All right, so that's everything. Now the question is, did I just break it all? I may have. Okay, so that's removed everything. Now we're going to run the make test. Broke everything. Okay. Not quite. Okay, so we know that we're able to generate, so the flex commands ran, Unicode string.o evidently ran. Okay. And then it tried to run Unicode string test. And why did it not work? because the build objects HTML escape.o was not created. Well, why was HTML escape.o not created? Or escape ASCII or percent or unescape. These are the generated ones. Okay. We got to figure this out. So when we're compiling our tests, so compiling Unicode string test, that is right there. It says we need test Unicode string object dir HTML escape. Oh, okay. I think I know what's happening. If I say -p, let me run that again and pipe that into less. Did you notice it tried to rebuild Unicode string? That was odd. Okay, so this is the top. And it's saying error, yeah. GenLab objects, HTML escape. Oh, that's the one I created. Let's get, these are all the variables. So there's an implicit rule to build objects %o. But if you match a specific rule, it won't match the implicit. I'll say that again. If you match the explicit rule, it won't match the implicit. And these are all the implicit rules, I believe. And if I look for HTML escape in here, this is the rule. File does not exist. File has been updated, successfully updated. Why? Because HTML escape. Nope. This line right here. Basically, I have a rule and I don't tell it how to compile. Okay, now I know what's going on. So, I want my, I'm getting there. I want my generic rule here to match each one of these as well, but because I gave a specific rule to give the requirements, the dependencies, it's never going to match the implicit rule. However, and this is the good part for pattern matching. So not how to use variables, writing rules. The rule syntax. I know it's in here because I remember reading about it, but I'm just going to go ahead and yeah, there's implicit search. I'm just going to go ahead and show you because I know it's in that file. Basically, what we can do is we can say these right here, lib objects. there. Lib objects. Those are all of the targets that share the exact same whatever. Then I say, but this is the pattern matching that I want to use to determine the, to say this. And in fact, I'm just going to hit save on that, and let's do test again. Why did it not like that? Oh, because the one it failed on was not the objects, it was the generated ones, right? So it should be gen lib objects, and they are in the generated directory. And now it's running through all of the compiles. Okay, yeah, this is a good thing. It's a big thing. Did that get us through all of it? That compiled everything. Okay. Not that I don't trust it, but I don't trust it. What I want to know is if I delete this here. In fact, oh, well, by the way, I just want to point out something. Not these, there. Compiling build objects Tang scanner.o. Used to it just said Tang scanner. I'm okay with that. What I want to know is if I get rid of all of that, did I even need to separate those out? Just get past the flex ones. Looks like we're compiling. Okay, so AST node unary. What did it not get? Did I accidentally delete that? Yeah, it got deleted. Well, where would that go? AST node use. This is very unfortunate. Question is, yeah, all of those are. There, now they're, well. Oh, I don't need all those anyway. I just needed the requirements. Okay. Made that a lot harder than it needed to be. Now we're doing the unary. Or, I saw it scroll past. But already this is a lot cleaner, and what I think is about to happen is maybe I didn't need to separate out the genlib and lib because, well, we're about to test it. Okay. And on the right-hand side, let's put this as a make test watch. Where was that command? There. All right. How do we test it? Well, first of all, if I change astnode.cpp, just open it and hit save, it will cause astnode.o to recompile, which should cause the library to recompile, which could, yeah. That's my thought. So, edit the source for astnode and just hit save. And yes, because the tests rely on the libraries, it caused that to recompile. But in general, astnode, the library, and then the test files. All right, now if I instead edit the include astnode and just hit save on that, I'm expecting a lot of stuff to rebuild. So the whole point is I now know that yes, the my dependencies are being honored. So I don't think I need genlib objects anymore because those are all exactly the same. Okay. And that means my apologies for writing this in the first place. HTML escape. Oh, and these there. So since I got rid of lib objects, now I have to go down to the bottom and get rid of genlib objects that I put on the shared library. There we go. All right. One last time, make sure it, oops, make clean, make test, just let it go fast. Or a lot faster than it would have otherwise. And I think I'm at a point where I want to do a commit. Everything compiled. Okay. So the first diff in our Makefile is getting rid of all of these commands. Yep. We'll just add the Makefile specifically, git commit, and what is our Okay. 182 deletions, 4 insertions. Yay. Now, for the hard part. There. So on the right-hand side, we've got all of this stuff. What I want to do, well, how about I stop messing up that stuff? There. I want a section, and we will call this dependency. Variables. Problem is, I definitely did not practice this ahead of time. So, if I call that's why the caps lock was on. If I call something dep for dependency, let's start with something simple. Singleton object pool doesn't rely on anything else. Well, but it might. Let me just look at these two. If I say garbage collected H PP maybe is equal to source slash singleton object pool dot hpp and dep error h, but that needs to be so what then is dep error h is equal to that relies on location. How do we reference location? Oh, right there. Error references location and, well, string. Okay. So the thought is, by saying that, if I use dep garbage collected HPP, maybe, okay, so maybe this will work, going about it this way. Error, so garbage collected relies on those. Oh, and garbage collected also macros. And this should be include. Yep. I was just making sure that that's what I was using down below. All right, include. Now, so Unicode string doesn't refer to any of these. But what I'm trying to get to is, what does program reference? So program HPP is equal to garbage collected. What else? Error, but sorry, dep. Well, what I was wondering is, should I do it as garbage collected, which will include error, or should I just specify error? I think I will not do it. Okay, I think I'll do it that way. Computed expression, which has not been written yet, dep computed expression HPP. Context HPP. And then macros. Oh, AST node. And what else? Oh, string. Okay. What is AST node? Memory location. Okay. So I think I am going to just list it. I don't care if I list it more than once. So garbage collected, error. So we've got ASC node, macros, context, Unicode string error, garbage collected, macros. Okay. So let's get the ones that we're missing. We're missing, so AST node, memory, location, and string. So AST node just needs location. All right. Location, memory, what was it? Oh, string. Okay. And context needs more. These are my, I'm just going to do this 1 page's worth and then start making my changes down below and see if it works. Depth context. So context needs, has computed expression. Did I do computed expression? No, I did not. I missed it. So computed expression is macros. There. Vector, see standard int, memory, garbage collected. Wait. Yeah. Computed expression is definitely garbage collected, or needs garbage collected. And are those the only two? No. Error. All right, and I was doing context. Context needs computed expression, optional, string, vector, any, macros, and map. So macros. All right, so I'm going to try this. Sorry. I expected that to sort these and it's not. Or maybe it is and I'm just... See if I do that. I put the include... Yeah. See, that seems to be working. I don't know why it wasn't quite doing that a moment ago. Okay, the first question is oh, and I still don't have the AST node.cpp. is equal to include opcode, macros, astnode.hpp, program HPP, and IOStream. All right. So the problem is I can't put these in alphabetical order because computed expression would come before something would come before error, but it requires error to be defined first. So now, dep astnode cpp all of this that's the point. And by using these variables, I should be able to one by one. And by the way, one by one, I have 60 files to go through, kind of. Having our documentation makes it nice. And if I can make it full screen and put it on the other screen over there, and yeah, there, zoom out a little, astnode array. Well, now I've already got program done. I don't have astnode array, but you know, it's like all that I need to do is program astnode array, and that's it. So I'll have to do the one for astnode array, which goes to astnode, and that's it. So they'll be faster. I knew the first one would be the slowest, but let's go back to this and do our make test. How about this? Make clean, make test. Make it a little faster. Yeah. Okay, so, I mean, it's still compiling just fine. And as we can see here, the change that was made, we're just cleaning up everything. So begin. Dependency variables. All right. So 34 insertions. But again, this is going to add more lines than it removes, but it will catch all of those edge cases where, in the past we've been, we'll make a change to the opcodes and something doesn't catch it correctly. All right, so where does this put us? I always say I do everything live in front of you, and I'm still going to do it live, but I'm going to fast forward through it because I have no idea. This may take 2 hours, and you don't want to sit here just for that, and we're 57 minutes into this. So what I'm going to do is I'm just, like I said, going to put this on fast forward, and I'll go from there. All right, so catch you on the flip side. All right, I have been going about an hour on this, and I definitely don't have everything done. In fact, I don't even have the computed expressions done. Well, all that I have are the AST notes. And I had to go back and forth a lot to try to figure out, well, what style do I want to do this in? Originally, I was having an HPP, and maybe I'll get rid of the capital HPP stuff. Because I was thinking, well, I needed the HPP and the CPP, and then I realized, well, the CPP is just going to be a copy and paste of the variable name down here, and so why not just put it in directly? Well, if that's the case and I don't need the CPP, then why even include the HPP? And in fact, okay, so it's still compiling. So if I %s HPP with nothing, and %s DEP with DEP underscore. I think I like the way that looks a lot better. It reads a lot easier, and I've still got a few weird things like, oh, this computed expression, that should be, oh, nope, I'm not wrong there. The question is that, no, that's the HPP one. So again, I couldn't go strictly in alphabetical order, but it got pretty close. A lot of these just had the dependency for the AST node, but not all of them. The range 4, for example, had more than one. And yeah. So where does that put us? Oh boy, a lot of work is where it puts us. I'm going to have to take a break. My arms are hurting. And from your standpoint, I went through it really quickly. Trust me, it took me a long time. So I'm going to call this at this point, and this is, we've got all of the AST node. I've been using the CPP file, but I'll go into the include. There we go. In the includes, that is the end. There's still a lot more to do, that's for sure. But the computer expressions will be easier to get through. We've already done a few, like the context, error garbage collected, and things like that. So it's not as bad as it looks. It's just I'm to the point I do need to stop. So, having said that, oh, had I not written that? We'll just rerun our make, and that'll be fine. And in the meantime, just to see what has changed. All of this, and I think that all of this is arguably easier to read. All right. And now, where does this put us? Of course, done. We're on episode 81. I remember that. Don't know if it's going to have to... Have we just been working on the Makefile? I think. Yeah, it's just when it was... That's all right. Episode 81. That is right, isn't it? 80 was the last one. Okay, so yes, it is 81. We'll push that. Now what? Zero 081. All right, and one of the last things we do is always check our lines of code. We haven't really changed that much. Our Makefile, though, has changed. So I was hoping it would get shorter, and in a way it has. But now we're being more explicit and more readable in our dependencies, and so that takes up a little bit more space. But that's all right. I think we're still in good shape and in a good place. So with all of that, like I said, I'm sorry that we didn't get it all done, but that's how it is sometimes. And it's, even if I had a more modern editor, I don't know of a faster way to do what I'm doing. There's not always a pattern to it. Things are out of order, and so I'm putting them in order, in alphabetical order, but they're not always... sometimes you have to copy 3 lines, sometimes it's 4, sometimes it's 1, and it's just not that direct. So this is what I'm doing. But again, like I said, we'll get done with it, and our project will be better off for it. So once again, thank you for joining me, and hope maybe at least you got some useful information about Makefiles. So thanks. Bye.